Welcome back. Problem 4-91. This problem is taken from chapter number 4, Axial Load, and book name is Mechanics of Material by R.C. Hibbeler. So statement is determine the maximum axial force P that can be applied to the bar. The bar is made from steel and has an allowable stress of 21 ksi. So you can see this is the bar where there is a P load is applied. Clear? There is a hole in this bar as well as fillet in this bar. All the dimensions are given. This height is 1.875, this fillet radius is 0.2, diameter of hole is 0.75, and this height is 1.25 inch and the thickness is 0.125 inch. So you have to determine this load P that can be applied to this bar. So let's start with the solution. As you can see, there is a hole and fillet in this, so we will need stress concentration factor. For that you can see this figure 4.23 and 4.24. We will using these terms, so we will find, you can see here this is W, R, H and T, here W, T and 2R. So we will find this W. So W from this figure you can see W is 1.875 inch. Now what about R? R is fillet radius, so R is 0.25 inch. What about this H? So H is smaller thickness. You can see this is H, so height which is 1.25 inch. And one more thing is thickness is 0.125 inch. And what about 2R, which is diameter? So you can see 2R is 0.75 inch. So we know all these things. So we will starting from fillet. So I will write assume failure of fillet. Failure of fillet. So we will find the stress concentration factor. So for fillet we will need figure 4-23. We will find the value of W by H, clear, and R by H. So W by H, which is equal to 1.875 divided by 1.25, that will give you 1.5, and R by H will be equal to 0.25 divided by 1.25, that is equal to 0.2. Now 0 point R by H is 0.2, so starting from this point you have to draw vertical line, clear, and that will coincide or intersect with W by H is 1.5 curve. So you can see this is W by H 1.5 curve. So it is intersecting at this point. So if you draw horizontal line, so this will be 1.7. So we will get K is equal to 1.7. Now we know that maximum stress or allowable stress is equal to K into sigma average. So K is 1.7 and allowable stress is 21 ksi. Let me check it. It is 21 ksi. That is equal to sigma average. So 21 is equal to 1.7 and sigma average is equal to P divided by this cross-sectional area. So cross-sectional area at this fillet point will be this height, which is 1.25, and this thickness, which is 0.125. So I will write 1.25 multiplied by 0.125. So from here this P will be equal to 1.25 multiplied by 0.125 multiply by 21 divided by 1.7, and when you calculate this P will be 1.875 kips. So that is the load that is applied on the fillet or a failure of fillet. Now we will find this P by assuming failure of hole. Again we will find stress concentration factor. For that we will need 2R by W. So 2r by w, 2r is 0.75 and w is 1.875. 1.875, that will give you 0.40. So again you can see 0.40 is this point. If you draw vertical line, it intersects this curve, and when at intersection point draw a horizontal line, you will get k is 2.2. So K is equal to 2.2. Now we know that allowable stress is equal to stress concentration factor into sigma average. So again, this is 221, this is 2.2 into P divided by area. Clear? So 21 is equal to 2.2 multiplied by P. Now you can see for this hole, you can see there is a hole and there is axial loading. So area will be equal to this 1.875 minus diameter of hole into this thickness 0.125. That will give you this portion and this portion. Clear? Because in tension this hole does not take any load, so we will write this P is divided by area. Area is 1.875 minus diameter of hole is 0.75 into thickness, which is 0.125. So again, if you calculate for P, P will be equal to 21 into 1.875 minus 0.75 into 0.125 divided by 2.2. And when you calculate it, this will give you 1.34 kip. That is the load due to the hole. Now you have one load is this one and another one is this one. So you have to choose P is equal to 1.34 kips that can be applied to this system without causing any damage to this bar. And that was all about this problem 4-91. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon for getting the upcoming videos, and also share my videos with your friends and help me in growing my channel further. If you have any question, you can ask me in comment section. Thank you for watching.